So in the previous class we have discussed regarding block diagram reduction techniques. So this is one of the important question which will be asked in the examination. So many of the question papers the question has been asked. So here this is a question asking for the system represented by this block diagram shown in the figure 1 and determine C1 by R1 and C2 by R2. Okay. So here R1, R2 both are inputs, C1, C2 both are outputs. So for a system generally we will be having one input and one output, and will be traveling from input to output, and meanwhile we will be calculating the gains which are there in the path. So here this is one kind of typical question asked in the examinations many times. So what is asking? Calculate C1 by R1, transfer function with respect to output C1, input R1, and transfer function with respect to output C2 and input R1. So in both cases he is asking for R1 as an input and C1 as output and C2 as another output. So we need to consider two cases. First one C1 by R1 case, and next one is C2 by R1 case. Okay na? So what we will be doing here means, while we considering C1 by R1 case, we are making R2 as 0 and as well as C2 as 0, so that output is C1 and input is R1. Output is C1 and input is R1. So like that we have to redraw the diagram. So how can you redraw the diagram means by eliminating R2 and as well as C2. So as you are eliminating the output C2, this block G6 having no value. This block G6 is having no value because it is open circuited and we are eliminating this output. So this diagram will be up to here only. So this block will not have any effect. And similarly, you are eliminating this input R2, so that the summing point will be directly added here. So this summing point is also not having any effect. Got this point or not? Now I am redrawing this diagram with respect to C1 and R1 as the output and input parameters. So the modified diagram will be like this. So I have eliminated this G6 block as well as this summing point. So therefore my diagram will be now becoming like this. Now in this diagram, what is your input? R1. What is the output? C1. So you are traveling from input R1 to output C1, and meanwhile whatever the blocks are there in this, we have to compress it, we have to reduce that by using our block diagram reduction technique rules. Okay na? So here if you observe this, it is nothing but a closed loop transfer function having unity feedback system. So generally a closed loop transfer function will be like this. So here the value of h is equal to 1, called unity feedback system, and the resultant of this complete block is what here? G of s by 1 plus G of s into h of s. Like that, numerator is G4 divided by 1 plus G4 into h of s is equal to 1 here. So therefore it is 1 plus G4 only. So eliminate this block, eliminate this entire section by using negative feedback reduction technique, so that my block will be now here G4 by 1 plus G4, and which is in cascaded with G5 as well as H1 as well as H2. If you clearly observe what will be the path here, the path is here. When you come like this, when I am coming from here H2 and the direction is like this, then I have computed this block as G4 by 1 plus G4. Then after that it is having a cascaded block G5, again having a cascaded block H1, and connected to this point. So as per the directions of the branches we have to go. Okay na? So we will do step by step First one is what here? We are calculating the negative feedback path here, G4 by 1 plus G4. Is that correct? Up to that, no problem. So that is my next step. So this is G4 by 1 plus G4. ఇప్పుడు ఏం చేస్తున్నామా? What you are doing here? From this you come from this point, H2 block is there, and that block is in connection with series or a cascaded connection, and G5 block is also there, which is connected in cascade, and H1 block is there, which is connected in cascade, and which is connected as a positive feedback to the summing point. So cascaded blocks, what we will be doing? Multiplying all the blocks which are connected in cascaded. So you have to multiply with this block H2, H1, G5. So what will be the simplified diagram after reducing this one? G4, G5, H1, H2 divided by 1 plus G4 is our complete reduced gain. So that will be written here. G4, G5, H1, H2 divided by 1 plus G4. What the point? Now it is very simple to us again. So this is the forward path direction, and you have taken this one as a positive feedback. Then what is the formula for positive feedback? G of s by 1 minus G of s into H of s. So for negative feedback it is plus, for positive feedback it is minus. So simply do the calculation. So this is your G of s, that means G1 divided by 1 minus G1 into this H of s is G4, G5, H1, H2 divided by 1 plus G4. So if you compute this one, the resultant will be like this. G1, this one, G1 by 1 minus G1, G4, G5, H1, H2 by 1 plus G4. And this is again cascaded with this block. So ultimately what will be happening here? G1 into G2 into this numerator term, this denominator term will coming to the numerator. So therefore 1 plus G4 divided by, so this will be doing LCM here. So 1 plus G4 minus G1, G2, G5, H1, H2. So simple mathematics, nothing to worry. Got this point? Again, so this is a forward path direction, and here it is a negative feedback again. So negative feedback, what we will be doing? G of s by 1 plus G of s into H of s. So numerator divided by 1 plus numerator into 1. So that will be like this, G of s divided by 1 plus G of s. So the resultant will be like this. And last, the block G3 is connected in cascaded with this block. So this will be multiplying here this G3. So ultimately the resultant output of first case is G1, G2, G3 by 1 plus G4 divided by 1 plus G1, G2 into 1 plus G4 minus G1, G4, G5, H1, H2. Okay na? So that is your transfer function by using block diagram reduction techniques. What you have done here, first of all, is asking for calculating C1 by R1 so that R2 and C2 becoming zeros here, and by making 0 this block is not having any effect, and this R2 is also not having any effect. So therefore redraw the diagram, and from that eliminate the negative feedback first of all. After that eliminate the cascaded blocks by writing in a cascaded manner, cascaded format, that means multiplying the blocks, and this is our resultant block. And after that again positive feedback, eliminate the positive feedback, this is cascaded, multiply it, again negative feedback, eliminate the negative feedback, and this is cascaded, multiply that. That's it. This is your answer. So in the examination you have to draw step by step, you have to write each and every transfer function for each and every step. And now case 2, C2 by R1. What you have to do here for case 2? C2 by R1. So C2 by R1. C2 is output, this is output, and R1 is the input. Okay na? So what you are doing here, you are making R2 as 0, similarly C1 as 0. When you are making C1 as 0, G3 is not having any effect, and this is already we have seen previous case. So this summing point is directly connected here. Am I correct? Now same principle, again negative feedback, cascaded, negative feedback, and multiply with the G6. I will show you the steps. So this is the second case. I have eliminated this C1 part and as well as R1 part. So this is my this is R2 part. So this is my diagram now. Again same, eliminating the negative feedback. So here this is my resultant one after eliminating the negative feedback, and after that if you come from here, again what are the blocks which are connected in cascade? H2, this negative feedback, G5 and H1, right? So these are the resultant of that, G4, G5, H2, 1 plus G4. Okay, and this is also cascaded, so multiply here, and having H1 as a feedback, so eliminate the negative feedback, positive feedback here. So that's why you are putting minus here, this is minus, and after that multiply with this G5, and that's your resultant answer. So this is C2 by R. Same process almost, just going through the directions. Okay na?